We are just coming from a workshop about developing sensors on the basis of nano and microtechnology. And this workshop has been organized by the Interreg project CheckNano, a cross-border project with the goal to develop methods to discriminate between toxic and non-toxic nanoparticles. Why is that interesting? Nanoparticles are in our all-day life since 30 years, and they have a lot of positive effects. But if they are too small, if they are of the size of biological objects like cells, membranes, or nuclei, then they can interfere with the nuclei, and that can have a toxic effect. So in order to develop some sensors that allow us to discriminate between toxic and non-toxic nanoparticles, we just need sensors that discriminate between the size of the nanoparticles. So we would like to avoid the very small nanoparticles, but get nanoparticles of right sizes.
In the course of the CheckNano project, we found that it's very challenging to detect relevant nanoparticles. That happens because they change their size when in contact with biological environmentals, like the liquids in our body. That also decreases their toxicity, but also means that not all the particles are naturally removed and can still be toxic.
One of the outcomes of the CheckNano project is that we can successfully detect particles which are both metallic and non-metallic, also using the methods which were developed during the project, for example using light scattering. In this workshop today we have discussed some of the newest sensing methods and what it takes to develop devices which will be able to detect nanoparticles in a simple, reliable and cost-effective way. Fortunately, modern sensors based on optical methods or fancy microtechnology cantilevers are able to detect even the smallest nanoparticles, thus reducing the risk related to potentially hazardous nanoparticles, which is especially important when we, for instance, thinking about particles which are generating with no intention to do so, for instance, plastic nanoparticles. Projects such as CheckNano are helping developing new sensing technologies. Here, we combine expertise for two countries and equally distribution between academia and industry. One can say that together we make our world more safer.
The advantage of using an optical method like dynamic light scattering for measuring small particles is that it's a non-destructive method that requires very low sample volume. It's quite fast, 2 minutes for measurements. It's in situ, so you're really looking at the sample as it behaves, and it's powerful because you can get many different parameters from it. Size, particle shape, molecular weights, and rheology are an example of parameters that can be obtained from light scattering. So dynamic light scattering is a super powerful method to measure the size of small and very small nanoparticles. How small can we go depends on the type of instruments you have and how well it's equipped and how well you're fitting the data that you're obtaining. So that depends on the equipment.